That's great.
Okay, girls, so are you ready?
Yes.
Sarah and Sandrine, do you want to begin?
Of course, so let's start. So,
Great.
Okay, so from the MOPSIA team, welcome to our HackaThymio 2021. We are very happy and enthusiastic to have you here. And allow me to introduce myself. I'm Sandrine Prunière, the CEO of the MOPSIA Association that produces and markets the star of the day, the educational and open source Thymio robots. So we are very pleased to have you all today to celebrate together the 10 years anniversary of Thymio, and very excited to start the official launch of the hackathon on artificial intelligence and Thymio. The MOPSIA team would like to warmly thank all of you, since without your participation in this special event, it would not have been taking place. So thank you to Learning Robots, Roteco teams, HES Valley, SUPSI, Stripes, Canopé, Poppy Station, and the last but not least, the EPFL Learn. So, should we move to the next slide? Perfect. So during this hackathon, you will get a fantastic opportunity to learn new skills, apply your knowledge, push your boundaries to open new perspective of innovation, and co-create together innovative artificial intelligence theme educational activities with Thymio. We hope you will enjoy and have fun during that special time.
So you have 15 hours and a half to co-create, express your creativity in teams of up to 6 people to bring relevant and innovative solutions to the different challenges proposed. We will share with you the different teams after the presentation of Mr. Luis Galindo.
But first, now, as you can see, we are going to introduce the agenda. So we have 2 evenings and 1 day to co-create. Thursday and Friday night, we start at 6 and finish at 9. And Saturday, we start at 9 and finish at 6. The moments in green light are the moments we are all together in this room. We are in the general sessions. And the link of the 3 days is the one you receive in your confirmation email. And we have also the dark green times that are when we are going to work in small teams, 1 virtual room per team, and we will make the distributions of the team after Luis Galindo presentation. And of course, the program, the agenda, can be found on the event website. And we are going to pass to the next slide. It is very important, in fact, to thank our juries who will evaluate your work, and they will present during your pitch on Saturday, but they can also make surprise visits to your small teams. So don't be surprised if they come to visit you. We are going now to introduce each of them.
So our jury is made up of 5 jurors. The first member of our jury is Didier Roy. He's a researcher at INRIA, French Research Institute in Digital Sciences and Technologies, in the optimization of learning using digital technologies. He's a member of the Flowers team. He's interested in the personalization of learning paths with artificial intelligence algorithms, the mediation of digital sciences, educational robotics, and technological transfers from research to the world of education. Didier is also an associate researcher at the Learn Center of the EPFL, École Polytechnique Fédérale de Lausanne.
And then we have Joël Rivet. Is a physics, chemistry, and computer science teacher in secondary schools in Bordeaux, France. For 6 years, he has also been working in the field of education robotics, especially on the Poppy and Thymio robots. He is co-editor of the MOOC Thymio and of the activity booklet Educational Robotics and Artificial Intelligence, Thymio and Scratch.
And the third jury is a woman among all these boys. So we have Margarita Romero. She's a full professor at the Université Côte d'Azur in France and an associate professor at Université de Laval in Canada. And she set up the Laboratoire d'innovation et numérique pour l'éducation ligne, a research unit in the learning science. She coordinates the school EI working group on the educational challenge of artificial intelligence in education and co-directs the international MSc Smart EdTech program. Her research focused on the study of transversal competencies, particularly in relation to computational thinking and creative problem solving.
So the next jury member is Thierry Vieville, Research Director at INRIA, researcher in computational neurosciences applied to human learning in connection with artificial intelligence and education sciences, involved in mediation of digital sciences and computer science education in primary and secondary education and teacher training through class code and its freely accessible and reusable resources.
So the last person is Johan Mollard, research engineer in robotics at the French-speaking association Poppy Station, which gathers actors around the open source robotics for education, research and art. The association is a former area research project that gave birth to the educational robotic and arm Poppy Ergo Junior for middle school and the humanoid robot Poppy Torso and Poppy Humanoid. The association also coordinates challenges with Thymio in France.
So thank you again for all your engagements. And now on the next slide, it is important that you know on what you will be evaluated to win the prizes. Sarah will describe in a few minutes. And we are going to explain the criteria. So the jury will evaluate three things: the solution, the restitution, and the implementation. And of course, each element have several elements. So first, for the solution, you have the relevance of the solution to address to the problem. So as a reminder, each team will work on a different team, so a different solution, okay? After, you have the innovation criteria. Here, we really want to push you to think outside the box. Be crazy, be imaginative, be innovative. And we also want the use of the solution to the largest number of people because we want to promote educational robotics among different populations. And we also need to focus on the accessibility criteria of the solution. So you need to ask yourself, is your solution or idea accessible, meaning can be used by everybody? So that's for the solution. Now for the restitution, you have the quality of the proposed deliverables. As Sarah said before, you have 15 hours to make a maximum to provide a deliverable. And the quality of the restitution or presentation, think about your pitch and how to convince the jury that your idea is the best. And finally, on the third point, on the implementation, so here you are going to be evaluated by the implementation criteria, the feasibility, can we use it? And the accessibility, yes. So is your idea, you think, acceptable? Is it sufficient to serve on the purpose that you are going to provide the solution? Think about your target and think about also the environment. And now on the next slide, we are going to make some explanations about what is expecting from you. So the restitution is in two simple parts. First of all, your resource, meaning, for example, if you prepare a document, a presentation, a video, whatever you create should be deposited on the Roteco platform, and they will be accessible for the community under Creative Commons, meaning that they will belong to everybody, to the community. And on the last day, I will show you how to publish on Roteco, so don't stress about that. And also on the last day, the second point is that from Saturday from 4:30 to 5, each team will have only 3 minutes to present its works, followed by 2 minutes of questions from the jury. So be very convinced. At the end of the presentation, the jury will deliberate, and in parallel, we will have an RT2T2 activity. And from 5:30 to 6, the winners will be named and the prizes will be awarded.
So right now we are gonna talk about prizes. We can pass to the next slide. The awards. Our jury will select a winning team. So each person of the winning team will receive a Thymio, a multiple charger for Thymio, a limited edition bundle for the 10 years anniversary of Thymio, with an activity to understand the bottom sensor and another one to understand the proximity sensors. Everything will be offered by Mopsia, and then a book of Thymio and Scratch offered by Roteco. Inside the two bundles that we create for the 10 years anniversary, you will find a QR code to find the activity online and all the materials to do the activity. Moreover, all the participants will receive a certificate of attendance to our HackaThymio, and we will share everything in our social networks, highlighting your creations.
Perfect. Thank you, Sarah. So we are going to pass to the next slide. So here you have some details about our online event with Zoom. So in fact, you may choose to have the camera on or off. On the online event sessions, they will be recorded and shared on social media. But when you will work in small teams, it will not be recorded. It will be really private. So don't hesitate to share, okay? And to do this on-off camera, it is located at the bottom left of your screen. And it's the same for the microphone. When the speaker is speaking, maybe turn it off so we can we don't have these noises that come.
So next slide. Now we will let the floor to Luis Galindo, who works at the Research and Development Department of Réseau Canopé on learning design, artificial intelligence, blockchain, micro-certification, and games and learning. He's also research associate at the Techne Laboratory of the University of Poitiers, and he is involved in the learning analytics course of the Smart EdTech master degrees at the University of Côte d'Azur.
Thank you, Sarah. And please don't forget to ask your questions by chat. Sarah will be happy to collect them and read them to Luis at the end of his presentation. Parliamo italiano, scrivi le domande sulla chat. Wir sprechen auch Deutsch. Sie können die Fragen auf Deutsch in die Chat schreiben. Et puis évidemment, nous parlons aussi français. Donc, si vous êtes plus à l'aise en écrivant vos questions en français dans le chat, n'hésitez pas. Luis, are you ready?
Yeah, thank you. So I will share my screen and we'll see if it works up. I don't know if you see my screen.
Yes, we see your screen in WhoopClap.
Yeah, the thing is that, but you see the presentation, right?
Yes, we see the presentation. Yeah.
Okay, because the problem is that this window, I will minimize this window up. Perfect, like that. I have the space. Great. Okay. So thank you very much for the invitation. And so I will try to, I don't know if it is a good thing to say that I will try to tell a story, but I will try to follow the different challenges that were posted in for the hackathon. And I will try to show some things that we make. So it will be a mix about the experimentations that we make around this subject, specifically the challenges of the Thymio hackathon, and the concepts that are involved with the challenges and the experimentations that we make. So as Sarah said, I'm Luis Galindo. So I work at the Research and Development Department of Réseau Canopé at the national siège of Réseau Canopé in Chasseneuil, because we are a national operator of the Ministry of Education in France. I am also a research associate at the Techno Laboratory at the University of Poitiers. So we work closely with the Research and Development Department of the Réseau Canopé. And I contribute to the Master Smart Tech with Margarita and also with Thierry Viville in the learning analytics part. So Thierry is more involved in the artificial intelligence part that is complementary with the learning analytic path. So the first thing before to start, actually, it was I wanted to ask you the question of what does artificial intelligence actually make you think? And if you want to answer this question, you can connect to WhoopClap actually. So you can connect to this address, or you can flash the QR code, And you can write the words, the first words that come to your mind when we talk about artificial intelligence. If you want, you can put the 5 first words that come to mind when we talk about artificial intelligence. So if you want, you can start. You can wait like 1 or 2 minutes, and we will see the answers, and we will compare this with some experimentations that we make with students, high school students, but also 10-year-old students and teachers. So actually we work with 800 teachers, I think, for this, and I will show you all of this work before to start. But if you want, you can put the 5 words, and then we will see what the words are there in the cloud that I will put there. So if you want, we can wait 1 more minute, and then I will show the answers. I don't know if everybody is connected to WooClap. It was okay?
I'm gonna connect myself.
Just put the 5 first words that come to your mind. We see just 1 word actually for the moment. I think it was okay for Jessica, for Didier also. I'm gonna wait 30 seconds, and then I think that depends also the answers on the public, I think, with which we work. So I think it will be interesting. So let's see. It's very interesting, actually. It is. I don't know if it is the same thing, but it is a similar thing of what you will see. We see the robot word in the middle, and that's interesting. And then we have a lot of words that are related with artificial intelligence, but robot is the first word. That's very interesting. Machine, ethics, WAL-E, smart, machine, neural network. But we see, and it's interesting because we see that robot dominates the words. So the idea of doing this, we did the same exactly thing. And you see that this comes to mind actually when we talk about artificial intelligence, the word robots. It was your case. And you will see that it was the case of all of experimentations actually, and all the interventions that we make with different publics, with the students, but also with teachers. So it's very interesting that all the time, this picture that is there come to mind when we talk about artificial intelligence. But sometimes when we talk to students, that will depend on which kind of students, but high school students, and we show them this picture, and we ask them if this means artificial intelligence, they tell us almost all the time that no, actually, it's not artificial intelligence, because we associate artificial intelligence most of the time with robots, with cars that they are autonomous and things like that. And this picture below, at my left, probably your right, is a picture that it was 1 year ago, I think, in England, and actually to automate the exams in England, the government put in place an artificial intelligence algorithm or model, and the thing is that the students were not happy with this and said they say the algorithm is unfair with us, and they put some word that it was fact the algorithm that is not in the picture, but it was all everywhere actually fact the algorithm. And probably it's interesting to talk, and you will see the why it's interesting to talk about the model and not only the algorithm. And that's the message that we are trying to pass actually when we are put in the elements that you will see next. And the interesting thing now is that we will work with a robot, with the Thymio robot. And just to tell you one of the one example of that we did with kids, actually we didn't use Thymio. We used a Thymio in a second time, but we wanted to confront kids with a humanoid robot, because they think about this all the time when talking about artificial intelligence, a human robot. And we show them that there's no artificial intelligence in this human robot because everything was programmed actually. And it was very interesting to understand that about the human robot. And that's why we like to work with the Thymio robot, because it's not a humanoid robot. But we did that in a second time because we wanted to confront them to this representation that they have in their head. And in the different experimentations, this was made with high school students. We asked the students to give us the 5 first words that come to their mind and to rearrange the words in order of priority. So the first thing that we wanted to see, so we did that with a pre-questionnaire, with a post-questionnaire. So we did that in a pre-questionnaire before the session that you will see in the next slide. And we asked the same questions to see the change, not of the representation, because for us, representation is something that is staying in our minds in the time, but for the perception of the students, that for us in our definition is something that is changed very fast. So we wanted to see the change of the perception about artificial intelligence after the workshop that we animated with this student. And in the left of the screen, we see the center of the representation that is dominated by 4 words. Robot, same thing as you. We saw future also in the words that you wrote just before: algorithm, autonomy. And in the first frontier of this representation, we see 3 words like program, intelligent, innovation. And we see other frontiers in this representation like technology, assistance, learning, deep learning, Google, adaptation, danger, computer science, data, machine, problem solving, strategy, and all of that. And it is interesting that after the workshop that we made, in the post questionnaire, we see some changes, and you will see why we see in the perception, or the center of the perception, we see that they added the word collaboration. We still see the word robot that dominated the perception before and after the workshop. Same thing for algorithm, but it was very interesting to see the word collaboration, and you will see why they added the word collaboration. In the first frontier, we see a program, autonomy, and something that is interesting is that data that it was in the 4th frontier, now it was in the first frontier. So they will start to think about the importance of data in all of this concept of artificial intelligence. Same thing for other words like replacement or limited and things like that. So it was very interesting, all the debates that were there. This is just the priority of the words, but we also wanted to see the quantity of the words, so the frequency of the words that they gave us. And we have some similar results. So in the pre-questionnaire, we have robot, future, program. We see also autonomy, algorithm, intelligent. And in the post questionnaire, we see something similar with the priority, like robot, collaboration that we see appear there, algorithm, autonomy, and data that we see also appear here. So if we put both things together in the pre-questionnaire, we see how robot dominate the representation of the students. Future is very close, program, algorithm, autonomy, intelligent, innovation, deep learning. And we see also a very positive representation that they have about artificial intelligence. It was very specific to this public that is familiarized, probably like you, with technological thing, with digital things, with digital technologies and things like that. And the post questionnaire changed a little bit. So robot dominates the perception of the students, but we see some words like collaboration and data, but also replacement and limited. That is very interesting how these words start to come, like limited, replacement, data, and how they become more and more important in the perception of the students. We did the same thing with adults, with almost 900 teachers, actually, asking them the same thing, actually, the 5 words, the priority of the words. And we see a very similar thing. Robot that dominate here, assistants that here, digital, tool, future. So you see personalization, adaptation, danger, privacy, and words like that. So it's very interesting to see a similar pattern with teachers and with the students. I put it in green the words that I think, because we didn't ask to the teachers if the words were positive or negative. Words that I think that they think they are positive, like future personalization. I think, in my perception, that these people are very interested in digital technologies, robotics, and things like that. So I think that they see artificial intelligence in a more positive way. But it's very interesting to see also the words danger and privacy there. So I try also to divide the words about the artifacts of robot, digital, computer, things like that, or how artificial intelligence works, like algorithm, programming, data, and also the usage of artificial intelligence, like assistants, like tool, and things like that. And the other thing is the positive words. One more time, for me, positive, because I did this classification. We didn't ask about this classification to the people that answer for these words, or that gave us these words, like personalization, future adaptation, and also some negative words like danger, dehumanization, privacy, and things like that. So actually, I applied some NLP, so natural processing language, to these words to see the negativity and the positivity of these words. And as we see here, we have people that think that artificial intelligence in a more positive way. And I think, because we don't know these people, these 900 people that answered to the questionnaire, what they think, but I think that it's people that is interested about the subject. So that's why I think they think about this more positively. But also we have some people that gave us negative words like capitalism, Google, in a more negative way. So we try to make this work also to understand the public and the biases that are in the answers. So that was very interesting. And that gave us the first challenge, is how to use Thymio robot to help understand some AI concepts. But probably to understand some AI concepts, the best thing is to start to ask yourself why to use artificial intelligence in the first place. And sometimes I do this analogy with using programming for some problems, and why we need to use artificial intelligence from other problems. The thing is that sometimes, and now that is a thing, that is a buzzword, artificial intelligence, we try to use artificial intelligence for everything, actually, and we try to put the term artificial intelligence in everything, sometimes just to sell something. And that's the interesting thing to ask, why to use artificial intelligence. So imagine, and I think you are familiarized with programming, you want to do a program that identifies when a people is walking or running. So the first thing or the first lines of code that you will write is probably the speed. So if the speed is less than 4, the status will put walking. But imagine that now we want to see if the person that is there is running. So we will add just an else statement. So we'll put if speed is less than 4, status walking, else status is running. Very easy. Imagine that we wanted to know if the person is in a bike. Very simple. We're going to add else if statement. If the speed is 4, walking. If not, if the speed is 12, running. If not, we are biking. And we can continue to add lines of code and rules actually to our program to recognize if I'm running, walking, doing bike, and things like that. But imagine that I show you this picture, and I ask you to determine if a person is doing golf. It will be impossible to do this kind of task with traditional programming. And that, in this kind of situation, in this kind of problems, it's interesting to think about artificial intelligence. So in traditional programming, we have the rules and the data. We write our program, and the program will give us the answers. So you express the rules in a programming language like Python or like Scratch. These rules act on data, and your program provide the answers. That's the case of we give the rules like walking is less than 4, running is less than 8, and things like that. We put the data, so the data is my speed, and then the program will give us the answers: walking, running, biking, etc., etc. In artificial intelligence, we will inverse these two things. You see rules here and answers here. Take a look at this, because we're going to put answers here and rules over here. So in artificial intelligence, we give the answers, the examples, all the labels, so we call it in different ways. We give them the data. In artificial intelligence, or we call it for now artificial intelligence, and we will obtain the rules. So the artificial intelligence system will determine the rules. So instead of trying to define the rules and express them in a programming language, you provide the answers, usually coded labels or examples, with the data, and the machine infers the rules. So in this example that I created, we can show them a lot of examples of or with walking, or running, with biking, with golfing, and then they infer the rules to recognize what I'm doing. So it's a very different approach, actually, that allows us to solve different kind of problems. I will show you another example that we work with, especially with young kids, to see the dangers and actually the challenges about this. And actually we call this the model. So we give the data and the model will make predictions with that data. And what we want to create is a model. And that's the important thing about the England problem that everybody say the algorithm, but actually the algorithm is not the only piece that is inside the model. It's just one piece in the model, but in the model there are other things like the data, the predictions that we make with the algorithm would make with this data, how to choose the algorithm and things like that. I will show you in a minute. So it's more interesting to talk about the whole thing, so the model. So another thing that it would be interesting before we enter into details is to try to define artificial intelligence. And it's interesting because in the 70s and the 80s, there was a joke about computer scientists that it was just cool things that computers can't do. And probably you know also the Turing test to test if a system integrates artificial intelligence or not. And it is if I cannot determine if a human or a robot, that a system, if is a human or a robot, when we're talking with the system, probably the system has artificial intelligence inside. Or the experience of the Chinese chamber. I mean, the chamber, in a chamber with a lot of instructions about Chinese, and some person outside of the chamber give me some papers with Chinese. I see the instructions and I can answer with the paper, with something outside of the chamber, but I don't speak Chinese. I just follow the instructions that are inside of the chamber. So I'm not using artificial intelligence. And sometimes when I try to define artificial intelligence, I like to concentrate in two words that probably will be interesting to use in the Thymio context with artificial intelligence. That is autonomy, the ability to perform tasks in complex environments without constant human guidance. So it's similar to what we saw with the example of walking, running, biking, and doing golf. And adaptability, the ability to improve performance by learning from experience. So I like to use these words and to give to participants, teachers, students, to create a definition. So we come out with different kind of definitions from here. And that's very interesting because we generate a very interesting debate with these two terms, creating a definition for artificial intelligence. So making Thymio learn with machine learning is the other challenge that we have in the hackathon. So it's interesting to talk more about machine learning, because artificial intelligence is not just machine learning. It actually is very old, and sometimes we can solve a problem without complex algorithms like neural networks in a much better way. It's the case of the learning analytics thing. Sometimes I showed the example that using neural networks, actually we have very bad results predicting something in learning analytics, and it's much more easy to use like a linear regression algorithm to obtain better results. Actually, that is very old on this thing in statistics and all of that. So that will depend on the problem, this thing. So I like to divide in three the concept of machine learning to understand this concept of model: the data set, the algorithm, and what the algorithm would do with this data set to predict. So the data set, the algorithm, and the prediction. So sometimes we start with a data set that probably you know also what a data set is, that it could be anything actually. It could be images, text, video, measures, likes, views, clicks, in the terms of the Thymio robot, what the information that the sensors capture of the environment and things like that. It could be anything actually when we talk about the data set. Then we have the algorithm, and I will show you a more specific probably example about the algorithm or the different possibilities of the algorithm. But it's interesting to understand what an algorithm is, that probably also you know if you're participating in the hackathon. So I will go much more faster about this part, that we have the entry, the steps to modify this entry, and the output that we'll obtain. We did that with the walking and with the walking, running, and biking program that we make. Actually, it was an algorithm to modify the entry with different steps and obtain an output that it was the result of walking, biking, or running. And then in machine learning, we have the last piece, that is the prediction. So right here, it's interesting because the first thing that we make is to create this this model that you can have different kind of models. And why I divide in three parts the machine learning term, because in most of the programs that you will find actually out there, and we will see some examples of machine learning for kids and other kind of problems, you see this same distribution. You see the data set here, you see the algorithm with the training, and you see the prediction that we're going to make with this data. And sometimes I use this example actually to show, especially with young students, it's very interesting to make this, to just recognize woman and man actually. So I use as an example, and usually in a real machine learning example, you will use like 80 or 70% of the data to train your model, and 20 or 30% to test if your model is good or bad, actually, if it's doing good or bad predictions. So I put it like 30 images there of woman, and then we're gonna put 30 images of men in the other side. So like that, we have two labels, woman and man. So up, I'm gonna put this, woman and man. And then I will tell you some anecdotes actually about this. So like that, we have the data, two labels, woman and man. Then we're gonna train our model. So we are preparing the data, we're gonna train the model, and probably if we wait when the model will be ready, this is very graphical, a graphical thing, but I did the exactly same thing with Jupyter notebooks to show them that this part of the algorithm, Google is doing actually everything in this part. But so we don't see what the model created. But in a Jupyter network, what I like to do is to do the data part, and then the training, I like to use different kind of algorithms. And actually, it's just 4 lines of code. I will show you an example in a minute. It's just 4 lines of code to try different kind of algorithms. For example, decision trees. So we're gonna use decision trees with this data to do these predictions. Or we're gonna use linear regression. So we're gonna use linear regression with this data and linear regression. Or we're gonna use neural networks. We are gonna add a little bit more lines of code to create this. And like that, I show the process to test this thing. And then we're gonna make the test. That is exactly what we do right now. When I do the test, I'm gonna do with images. And I have some images just to test. So it's images that the system didn't show, actually, for example, this one. So it will recognize as a woman. I think, yeah, the system is good because it is a woman. For example, this one, I think it will be a man. Oh yeah, it's a man. And actually the system recognized me as a man, so that's a good thing. But imagine this picture here. When I put this picture, I think we agree that it is a woman, but the system thinks that it is a man with 100% of probability that it's a man. And actually, we ask the students what the system thinks that this person is a man. And this is the interesting thing of what I saw you before, because the system thinks, I will just hide this thing actually up. Actually, the system thinks that probably created the rule that all of the people that have short hair is a man. So you remember how the model works. So we give them the answers, we give them the data, and the system will create some rules. And I think that this system created the rule that the person with short hair is a man, actually. And that's very problematic. So we have to retrain our system. And with kids, it was very interesting because we work with this example with 10-year-old kids. And when we and then the kids wanted to test if the system recognized kids. And actually, the system didn't recognize kids. So they told us, yeah, we have to give them more pictures of kids so the system will be improved to recognize other pictures. So the first thing is to give a lot of examples so the system can see a lot of examples. The other thing is diversity of the examples. We have to give the system a lot of diversity of examples so the system can recognize different kind of things, because if not, we're going to enter to different kind of problems. For example, Amazon that wanted to automate the CVs in the company, but the problem is that most of the engineers were men and white. So the system thought that be a woman, it was bad actually to work at Amazon and things like that. So we can enter to, and we have a lot of examples that probably you know about artificial intelligence. Same problem with what happened in England when evaluating the students. So are the dangers and the ethical part of artificial intelligence. And then it's interesting to talk about the prediction. So when we do some predictions here, we have, for example, this picture of Instagram, and I asked them, what is the prediction of this picture? The prediction probably of this picture is what I want to click, because Instagram, the objective is to make me click on the publicity actually of the picture. And then Instagram worked with a system, with the algorithm, and the system used some data set. And I asked them, what data set do you think that the system is using? Probably or clicks or passive clicks, probably who I follow and things like that. Another interesting example is the spam or not spam mails. So what I'm trying to predict if something is a spam or not a spam. An algorithm is trying to predict that with a data set, with some data. Data, it could be the mails that I put it on the spam, how the mail is written, so the content and things like that. So we list actually all of these things. When we work with kids, with small kids, these examples are very difficult to understand because Instagram, it will be difficult for a 10-year-old. Sometimes not, but for the half of the class, sometimes it's difficult. So we work with teachers actually to define analogies to allow us to work with different kind of kids that have different kind of ages. If, for example, this is a work that was made just with teachers. So they come out with example of characters, and we give the characters different data that we know, and we have to make the predictions of the plates or the sandwiches that they will like actually to eat. So we have Sarah, for example, that likes some fish and vegetables, and we know some other data of Sarah, and we try to predict some plays that she will like. So like that, we do some exercises actually with the kids before entering to more complex problems, before entering to robotics, before entering to training models or creating models and creating especially projects. So how can the Thymio robot can be used to create behaviors, for example, inspired by animals? And this is an interesting question to follow the challenges about the Thymio thing. And to abord this question, probably it's interesting to understand the difference between supervised learning, unsupervised learning, and reinforcement learning. So in supervised learning, we do exactly this thing, what I did here. Actually, is a human that supervises all the training, actually. So I choose the data that I will use, my labels, my data, then I do the training, then I do the test and all of that. So it's a human that is supervising all of this process. So we have the input data, and then I put in the algorithm, probably is the model actually. And in the model, I will choose some training data, like I did with the 30 pictures of women and men. And this human will create also the labels. In my case of women and men, it's 2 labels, women and men. In this case, is probably dog, cat, and I don't know if it is a specific animal, but bird. And then we do the work. So we give them examples that we don't know, and then we divide the output. And like that, I can test my model with supervised learning. Is exactly what I did here. And we have a lot of this kind of examples. So I show you the example of supervised learning. But when we work with data science, and probably the first example that you will see when working with data science is this kind of data. You will obtain all the time data in this way, actually in a table, in a relational table with all the variables here in the columns and all the observations in the rows. Here is an example of the Titanic. Actually, it's a very classical example when you are doing or you are learning data science, because what you want to predict is who survived and who died in the Titanic. And you will use the other variables that you have there. For example, you have some variables that are not interesting, some variables that are interesting, some variables that you can transform to be interesting. So I will not show you all the examples, but I work this with high school students. So we use a Jupyter Notebook that allow us to write code, Python code. And then we have all of this EDA process that is to explore the data and to choose the good variables. The other thing is that the machine will not understand male or female. It will understand 0 or 1. And doing this process actually is sometimes very complicated when you have a lot of variables. And in this case, for example, you have the class, first class, second class, third class. So probably it's a very interesting variable, because when you see the data, when you analyze the data, you see that most of the people that died, it was in the third class, not too much in the first class. Same thing for male and for women and men, because you see that a lot of men died and not a lot of women. And like that, you can determine if a variable is useful for your model or not, actually. And this task is very difficult. The age is very interesting, because people between 18 and 25 or 30 years old died also in the Titanic. Probably kids would try to be saved before. Same thing for old people. So it's a very interesting variable that you can take and things like that. And for example, you try to clean also the data and all of that. And you have other data that is not interesting. For example, cabin. It could be interesting or not. I think in my model, I use cabin there, and also fare, because if I paid a lot of money, probably I was in the first class when I don't have the data for the first class and things like that. And you see the work that you have to make with the data set to predict if some people survived or not. And we use 80% of the data to train the model. And when I train the model, I use different kind of algorithm, SVM, decision tree, and it's just 2 or 3 lines of code to do this, actually, to use the algorithm that already exists actually to make the prediction. And then I test the different algorithms, and I see that decision tree give me better results than SVM or neural networks and things like that. And I say, okay, I will use decision trees for this model with this data. It probably will be good because it has 80% of good predictions. So in the data set, I use the 80% of the data for training and 20% of the data for the predictions. Another interesting example, or another classical example actually, that we use when we are learning data science is the plant species. Actually, we have 3 species, Setosa, I don't remember the other species, versicolor and virginica. And we have actually the length, the sepal length, the sepal width, the petal length, and the petal width, actually. And with this data, we're going to try to predict if a plant of a flower, it is Setosa, versicolor, or virginica. And we do the same thing as with the Titanic, actually, 80% to train the model, and we see if the model recognizes actually if a flower is one of this kind of a species, actually. So then we have unsupervised learning. That is a different process for solving different kind of problems. In unsupervised learning, we have the input data, and then the model will propose us different kind of groups of data, we will say. Sometimes I try to give the example of the supermarket. Imagine that you go to the supermarket, and with your card, we're going to have your data of what you are buying. And probably I want to analyze all of this data of all of the clients that come to the supermarket. And probably I can, and it's the human that will label the data there. So the system present me with the people that buy, I don't know, organic things with vegetables and things like that. And probably other people that buy Coke with hamburgers, with things like that. And me, I would label, oh, these people is the the good help people, and this people is the bad help people, and things like that. Actually, I don't know if it is a good example, but this kind of problems, unsupervised learning is interesting. And probably reinforcement learning is interesting in the Thymio context, because in the reinforcement learning, we try to simulate actually how we train animals. So we have an action to the environment, and then we can give like a positive label and a negative label of the action, and then we can train a system. And this kind of systems is very interesting when the system is interacting with the environment all the time. It's the case of the alpha robot of Thoma, that the system is interacting all the time, and it learns from these interactions. And actually, probably Didier was thinking about the same thing, but Tuesday, I was with the AI for Teachers Erasmus Plus project that wants to work with teachers and all of that, with different countries, Ireland, Slovenia, and all of that. And actually, we're talking about Thymio, and actually we're saying that probably will be interesting to have a camera on Thymio to do the same thing as Alpha, the Alpha robot. And I think it could be an interesting project to work with artificial intelligence. So Thymio can recognize the environment and all of that kind of things. So we have the three first challenges there. So how to use the Thymio robot to help understand some AI concepts, making Thymio learn with machine learning. How can the Thymio robot be used to create behaviors, for example, inspired on animals? And I think that you can use, and probably you know, a machine learning for kids. If you work with the Scratch, that is one of the prizes of the hackathon, Scratch with Thymio, it could be interesting because you have the page, now it's in French, but the original page is in English, and you have the page in different languages. It was translated, I think, in most of the languages, actually. We will see, but I think, yeah, you have all of the languages there, and you have different examples that you can explore in the hackathon. So for example, recognizing things, and you see the kind of the recognition here, for example, numbers, text, images, and you also have, if it is a supervised learning, unsupervised learning program, or you see the Titanic example here, you have the Titanic example here, so you have a lot of very, very interesting examples. And all the time, you will have the same scenario here in machine learning for kids, because as we saw here, we have the three data, the algorithm or the training, and then the prediction. And you will see that in machine learning for kids, you have exactly the same thing, actually. The good thing is that you can export your model, use it with Python, with Scratch, and things like that. For example, here, I will use it to recognize, I don't know, images, test, and you will see that you have the same format, actually, to train your model or to create your model, and then you can connect to Scratch, but you can practice with examples that are already there, actually. And you see, you have the same thing. Here, I will create my model, for example, woman and man. So I will define my labels. Here, I will use an algorithm to train my model with this data and to make some predictions here that I can use with Scratch or with Python. So very interesting to answer these three first challenges of the hackathon. And then I resemble the other three challenges, that is how to use Thymio robot and an AI to help students with special educational needs, how to create an activity with the Thymio robot to raise awareness of the issue of responsibilities in contexts involving machines and algorithms. And the last one, that is how to create an activity with Thymio and AI in the extracurricular context. So it's very complementary, the three challenges that we have here. And I think that it will be interesting to talk about the collaboration between AI systems or between machines like the robot Thymio and the people actually that is there. So I wanted to ask or to tell you a story that started in 1997 when Garry Kasparov lose a match with the Deep Blue robot. And actually Garry Kasparov accused IBM that there was humans actually behind the robot, and that's why he loses the match. And in 2004, 2005, you will see some papers that Garry Kasparov and other researchers published about this kind of experimentation. For example, he was interested in the complexity of different kind of interactions. So, for example, one human versus a machine, a human and a machine versus a machine, and a machine versus a machine, and all of that. So he was trying to make all of this mix, we will say, of human with machine versus machine, human with machine versus human, and what happened about all of this. And what was interesting, that the human with the machine beat the human. So probably it's not surprising, actually, because the machine alone beat the human. But what is interesting is the human with the machine beat also the machine. We could think that the machine with the machine will be reduced by a human that is less efficient than the machine, and it will make lose the machine versus another machine. But it was not the case, actually, because the machine with the human won versus the machine. So the interesting thing, and this could be probably explained, because human intelligence includes several dimensions, which makes the duo more efficient due to the man-machine collaboration in a chess game, while AI includes only one dimension. Being able to solve a problem does not tell us anything about the ability to solve another problem. So the interesting thing probably is it's not the human and it's not the machine, but is the collaboration between both. And another interesting story also is about tools, and is to talk about one of the fathers of artificial intelligence and a lot of more things. In 1960, in his Douglas Engelbart. I don't know if you know the experimentation of Douglas Engelbart, but for Douglas Engelbart, imagine that I give you a pencil and I ask you to generate a lot of ideas about something. So the pencil will help you to put your ideas on the paper. So it will augment in some way the human capacity. So it will facilitate the process of generating ideas, because I will write with the pencil and I will connect some other ideas. But imagine now that I will add a brick to the pencil. It will be very difficult to you to write some ideas with the brick and the pencil. So we reduce your capacity to generate new ideas. So this is very interesting, because for Engelbart, a tool did not simply facilitate something. It enabled new ways of thinking and living that were not previously possible. And actually, Douglas Engelbart saw the computer this way, actually augmenting the human capacity. So a strong link between a novice person and a machine will be more effective than a machine, and will also be more effective against an expert person with a weak link of a machine. This means that in a collaboration between humans and machine, the most important part is not AI or the AI system or the machine, not the human either, but their collaboration. And this is why you saw at the beginning of the presentation the word collaboration in the center of the perception of the people, because we work at this kind of collaboration between the machines and the humans, actually, and how we can work in this collaboration in a simple way or in a complex way. So while processing numbers is AI's greatest strength, that's why they won in a chess game and other kind of games, it is also its greatest weakness. Currently, the only way to train an AI system is to allow the machine to classify answers as right or wrong. This is why a machine with an AI system is better than a human at playing chess. The machine must classify answers to win, tie, or lose, and for the machine, it's very easily to calculate, to do a lot of calculations. But in a situation where we cannot rank the answers in a single dimension, such as win, tie, or lose, the machine will not be able to find a solution. This is the case for tasks like discussing, creating an invention, art, or formulating an hypothesis. Well, we will need a human to do all of these tasks. In all of these tasks, we need a human who can deviate from a single answer and ask why, how, what if. And it's in this collaboration that interesting things will happen. So I don't know if it's a good thing or a bad thing to say what I put it there, but I think that AI systems are better at choosing answers and humans are better at choosing questions in this kind of collaboration. Because imagine that the machine will give you different kind of answers when you ask a question, and probably then the human can ask another question. But for the machine will be very difficult to do this. So we can put the machine to calculate things and do this kind of things, and the human to ask some questions. And it is in this interaction, in this collaboration, that it will be interesting, or that we create interesting things and generate interesting things. So to have a resume of the other three challenges, how to use the Thymio robot and AI to help the students with special educational needs, it's interesting to see a collaboration between these systems to create something that is interesting. Is how you can integrate the robot Thymio to do these kind of things. How to create an activity with the Thymio robot to raise awareness of the issue of responsibilities in contexts involving machines and algorithms. Another interesting thing that I think we can imagine different kind of things. How to create an activity with Thymio and AI in the extracurricular context, because it's very interesting to work with with things that goes beyond the curriculum and things like that, or that are that transcend the curriculum is more in a more interesting context. So some examples, and actually it was a teacher that gave me this example, that probably you know, this quick draw application that was made with the. And you see, it's very interesting because we can draw the things, and then the machine will propose us different kind of drawings. And actually, so I would close actually this, because it's doing a lot of things. I don't know if you hear that. And actually, Google do a lot of experiments like that. And probably it will be interesting if you see some experiments, so we can use we can inspire ourselves in some experiments, and ask ourselves how we can work with Thymio to develop this kind of collaboration. And sometimes we see this kind of interaction. So in a very simple way, actually drawing, so it will help me drawing things, but I will help the different draws to build some different kind of things. So I think this is very interesting also to explore the other three challenges that we have. So like that, we explored the 6 challenges that we have. We explored a little bit the different concepts about artificial intelligence, and we also explored the different potentials and the importance probably of the work collaboration, the last 3 challenges. So I think it will be a challenge to work with Thymio and artificial intelligence, but I think we can build some very, very interesting things, especially with creativity, or to develop a different kind of creativity. So if you are, I think it is a good idea to use machine learning for kids, because you can work with Scratch and things like that. I don't know if you have a format for the deliverables, but I think even ideas to put in place with the Thymio robot are very, very interesting, and probably is interesting to keep all of these ideas. So I don't know if you have any questions, remarks. Let me, I don't know how to come back.
Thank you, Luis. Thank you, Luis, for this beautiful presentation. So please, the participants or anybody that has questions for Luis, I think that you can unmute your microphone and ask the question, because we are a few, so you can unmute and ask directly the question to Luis. He's here for you. So don't hesitate to ask your questions. And maybe I will begin with the first one, because the first one is the most difficult one, Luis, is, you know, the example that you show with the sandwich of Sarah. Is it also on this machine learning for kids that the teachers can go there and have this example?
No, because there was an example. Actually, we make an experimentation with a teacher, and that's very interesting too, about the collaboration between researchers, because we invited some researchers and things like that. Because the teacher, the group of teachers who we work with say that it was very great for us because we learned a lot of things, but I think researchers learn a lot of things from teachers, because without teachers, all of these activities were impossible. And so this example of the sandwiches is not in machine learning for kids, and probably it's an interesting thing to talk about Dane Lane that developed in machine learning for kids to connect with teachers. And sometimes the language is a barrier actually for us, because sometimes it's in English, and sometimes the teachers who we work with doesn't speak English, and we have to create a bridge between both of them, because they had a lot of interesting ideas to integrate, and Dane Lane is open to integrate all of these ideas, analogies, and things like that. And actually, with the laboratory Margarita, we were thinking to collect actually all the analogies developed by teachers, because sometimes they wanted to explain neural networks and things like that in a very easy way to a 10-year-old. And actually, they developed very interesting ideas. And actually, what is interesting is to talk with them about these analogies and say, oh yeah, that's a good idea. Probably we can have this kind of thing. And I think in the fusion of this different experiences with teachers, researchers, practitioners, and all of these actors around this subject, we can develop very interesting things. But suddenly, the sandwich example is not yet in machine learning for kids, but probably will be a very interesting thing to work with the characters, with the sandwich that they can create. And probably it's a project that we can develop in a Scratch. It's not so difficult to develop this in a Scratch and put it on as an example in machine learning for kids. So it's a very good idea. I don't know who put it the question, but I think it's a very good idea to do this and to give this to Dane Lane to integrate there, because he's very open. A lot of the examples there, it was not him that developed it, but it was developed by other people that were testing machine learning for kids. And probably the connection with Thymio, I don't know if there is a connection with Thymio and machine learning for kids, but it could be interesting to work with robotics and things like that to talk more about this kind of activities that we can create with machine learning for kids. There's another platform, is a friend of us, is Stefania Druga, that developed another platform that is very similar to machine learning for kids. That is, I forgot the name. Actually, it was here, but I just forgot the name. But I can. Sorry.
It's Cognimate.
Cognimates. Thank you. And
there are more examples. Also, in France, Vita Science developed its own AI blocks based on teachable machine.
I talked with the person from Beta Science, and actually it's a very interesting project in the way also that we can write code in Python and in a Scratch or just next to Python. And we were talking about how we can integrate Pygame, for example, to doing games and things like that. And it was a very interesting project, Beta Science. I hope to talk with them next week in Educatech. But it's another interesting platform that we can use. And Cognimates also is another interesting platform that has some other examples too that you can use actually also with Stefania, that also is very open to integrate things and all of that.
Thank you, Luis. Thanks a lot for all this presentation. It was really interesting. I have myself a question actually. Is there any particular language you suggest to use for creating machine learning with Thymio? Do you suggest one or another? What do you think?
I think that depends on the experience also. I think the participants. I was thinking about a Scratch to develop and think, because it's easy to connect actually with machine learning for kids, with Beta Science, for example, also.
Yeah.
And a lot of teachers use also Scratch there. We had a problem. I don't know if you are with the Scratch, but the other day some person in the ministry tell me that Scratch is not RGPD compliant. And that has some problems with there, and that the ministry was evaluating of recommending Scratch or not. I don't know, but I think there's a big community around Scratch, and it's very interesting. Python, of course, is very interesting, but it demands probably more experience. So I think it will depend on the experience. But even develop some ideas, I think is very interesting, because if we connect then with other people that can develop different kind of things, I think it will be very powerful also in the hackathon context.
Thanks a lot for your reply.
Yeah, and the question that you make about the vision in China and Europe is interesting. It was not the subject here, but we talk about this in the AI for Teachers Erasmus Plus project, because it's an international European project. And And we talk about the vision about personalization, adaptation, all of this, and how we work with teachers to pass exams. The example of Skirl, for example, that is a tool that uses artificial intelligence that help kids to pass the equivalent of the bac in France, the last exam in high school to enter the university. And actually it became a multi-billion company because it's helping kids to pass the exam. But sometimes we ask, and actually we ask it in UNESCO to the Chinese, because there are a lot of Chinese people around this subject. Probably we are training kids to pass the exam, but not to learn. And it was an example that we showed in the learning analytics hackathon in Lauria University, in the Lauria laboratory in the Lorraine University. And it was a group from, I think it was from the Netherlands. And they trained themselves actually with an application to pass a test in French, but they didn't speak French. And they passed the test. So the application was very good. And she said, but I don't speak French. So I trained myself with the application to pass the exam, but I didn't learn anything. But it was great, actually. I passed the exam. So sometimes probably we are using this application to pass an exam, but not to learn. And that's very interesting too, about the vision of China and Europe. Yeah, it was a very interesting debate that we have also in UNESCO, also because Chinese people dominated the event with a lot of money too. And the United States also is interesting because they don't have the same exact vision as Europe. So it's interesting to have all of these questions. Probably also we can touch all these questions with the last three. I don't know if we can abord these questions with the last three challenges. I don't know, but I think it's very interesting also, all of this part that generates a lot of debates also.
I see. It's really interesting actually to see.
I make the comment because in fact I saw a documentary when you have like the vision of the European people that we are like afraid of machines, of robots, and more the Asian people that they see like a tool that it's helping them to make an action, an activity. And it is very interesting because I see on my activity when I explain, okay, I work in a robotic community, they are like, but are you going to replace the teachers by robots? It's the first question that people that are not on the field ask. So for me, it's very interesting to see these kind of questions and that you have to explain, no, we have educational robots that you use like a pencil, it is a tool, but it's interesting to see this kind of different ways of thinking.
In the questionnaire that you see that we make with high school students, it was very a very specific high school student that were interested about digital technologies and all of that. But in the debates, actually, you see the word replacement. Though it was in the post questionnaire that appeared there in the post questionnaire, and actually they not necessarily saw replacement as a bad thing. Actually, in some high school students, I was very surprised. Told me, but some jobs that nobody wants to make, we can automate this and replace humans by robots, and it generated a debate. Not the whole class would agree with that, but this kind of work is very interesting too. That this kind of debates that we can generate in the class are very powerful, I think. And it was very interesting because all of the students were very involved in the debate and all of that about all of that. And that's why the collaboration thing was interesting for this debate, that it was not the replacement of teachers, the tools that we use, but how we can look for a better collaboration between the systems and the humans.
Thanks a lot, Luis. Sophia, do you think, do we have other question for Luis?
Luis, il parle aussi français, donc pour ceux qui se sentent plus à l'aise en français, vous pouvez aussi poser vos questions en français, il n'y a pas de souci. Et puis, soit vous écrivez dans le chat, soit vous prenez la parole directement.
It's only a comment because the presentation was great and very complete, so it's hard to find questions, but we appreciated a lot of things. including this view on collaboration between humans and machine, and the different solutions that were illustrated.
Merci beaucoup, Louis. Et puis, si on n'a pas d'autres questions. Ah, I have...
It's just me a comment. I just wanted to thank you for the stories. We teach children through stories, and I really appreciated them tonight. Thank you for intertwining that.
Yeah, and actually this was generated by teachers also, and that's why I remark all the time that especially when it was Laura, the teacher that worked it, she remarks all the time, I learned a lot on this project, and that's good. And actually we learn a lot also from her, and sometimes we don't remark that actually, that a lot of these ideas of using the stories and all of that come from her. So I think it's very interesting to remark this powerful collaboration between the teachers and the other actors also. I think is very, 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 very powerful, and stories work very, very good. Analogies too work very good. That's why I think we will try with Margarita to look for other kind of analogies.
Merci beaucoup, Louis. D'autres questions? A super presentation. Thank you so much. Your presentation was beautiful with these beautiful slides, really.
Thank you.
Great.
I will stop the recording now, okay? Just to let you know. Up. Okay.